A particle, initially located at the origin, has an acceleration of 1 meters per second squared in the y direction, in the positive y direction, and an initial velocity of 5 meters per second in the positive x direction. Find the vector position and velocity at any time t, and the coordinates and the speed of the particle 2 seconds in the past. So our acceleration here is a vector. And we can see from the unit vector here that it's only accelerating in the y direction. But we can see from the velocity vector here, that its initial velocity is 5 meters per second moving along the x-axis. And this is indicated by the I unit vector here. So in this example, our particle has a constant acceleration. And because it has a constant acceleration, in other words, an acceleration that does not vary over all of time, then we can use the kinematic equations of motion to determine the position and velocity of this particle here at any point in time. And then we can substitute in this time to find out exactly where it was in the past. So I've covered the equations of motion in a previous video, and these equations of motion related back to one-dimensional kinematics. But because vectors can be split up into their x and y components, we can apply the equations of motion separately to each axis. So in other words, we can find out how the particle is moving along the x-axis, no matter where it is on this plane, and then we can find out how it moves along the y-axis, no matter where it is on the x-plane. So to find the position of a particle moving with constant acceleration, we can use this equation of motion. So the final position of the particle in the x and y plane is equal to its initial position plus its initial velocity multiplied by time plus half the acceleration both along the x and y plane multiplied by time squared. Now the position, the final position, initial position, the velocity, the initial velocity here, and the acceleration are vectors. And this equation represents both the x and y components of the motion. But we can split this equation up and focus solely on either the x dimension or the y dimension and combine the result later. So if we were to plug in our values now, the acceleration velocity, into this equation and write it out in full, our final position would equal to the initial position, which is the particles located at the origin. So we have 0 I plus 0 j meters, where I is the unit vector along the x-axis and j is the unit vector along the y-axis, plus the initial velocity, and we can break this up again into its I and j components. 5.00 I plus 0.00 j meters per second multiplied by time, plus half the acceleration, which is equal to 0 I plus 1.00 j meters per second squared multiplied by time squared. And this gives us an equation of 5.00 Ti plus half 1.00 t squared j meters. There's another equation of motion that we can use, which gives us the final velocity at any point in time, which is equal to the initial velocity plus the acceleration multiplied by time. And again, we've got our initial velocity here and our constant acceleration, and we can just plug these in. So 5.00 I plus 1.00 t j, and that's meters per second. So now that we know where the final position is with respect to time and what the final velocity is, we can plug in our time into these equations. So we want to find out where the particle was 2 seconds before the particle reached the origin. So t is equal to minus 2.00 seconds. The position is equal to 5 multiplied by minus 2 plus half times 1 minus 2 squared. And that is equal to minus 10I plus 2.00 j. And that's meters. And the velocity at minus 2 seconds is 5.00 I minus 2.00 j meters per second. And to find out its speed, we can use the Pythagorean theorem to find the magnitude of the speed. So from the velocity at minus 2 seconds, we know that the particle is moving in the x direction at 5 meters per second, but also moving in the negative y direction at 2 meters per second. So by using the Pythagorean theorem, we can work out the speed. Which is equal to 5.39 meters per second to 2 decimal places.